Okie dokie, we're here in the end of section 1.2, and it is near the end of this section that the author gives you three particular graphs that he feels you need to know, and so we're just going to go about graphing them in the way that the author gives in the examples section, or the examples of how to graph them, and that's through finding the intercepts, okay, and then plotting points, and then finding whether or not it's symmetric and stuff like that. So let's start with x is equal to, or I'm sorry, y is equal to x cubed. So we know if we plug in, if we make both, not necessarily, if we plug in negative x, okay, we're going to get y is equal to negative x cubed again. Alright, because it's an odd power, it's going to stay at negative x. Alright, but if we plug in negative y, we get negative y is equal to x cubed, and that's clearly different. However, if we plug in both negative y and negative x cubed, the negatives cancel each other out, and you're left with the original equation. So this graph is symmetric about the origin. Okay, and now let's find an intercept. So if x is 0, we're finding a y-intercept, all right? And if x is 0, y is 0. If y is 0, x is 0. So we have a common intercept at point, let me do it in green, same color as our graph, at 0. That is both a y-intercept and an x-intercept. And if we do a little table here, we have our x values, our input, and then our output. So if we have negative 1 cubed is negative 1. If we have negative 2, that's negative 2 times negative 2, which is 4, times negative 2 is negative 8. And if 0 is 0, and when we plug in 1, we get 1. Plug in 2, we get 8, etc. So at 1, we have 1. Negative 1, we have negative 1. 0 is at 0. At 2, we have, let's say this is 8. Let's say this is negative 8. 2. And if you keep going, your graph is going to look something like this. And as you can see, this is symmetric about the origin. You can flip it around the x-axis and then subsequently flip it around the y-axis, and you'll be given the same graph as you had previously. So that is y is equal to x to the third power. Okay. Now we have y is equal, or x is equal to y squared when x is 1. I'll do this in cyan. When x is 0, y is 0. So it has a y-intercept here and an x-intercept. When x is 1, okay, we have, let's see. Well, first of all, you can write it like this. When y is, you can write it, take the square root of both sides, so square root x is equal to y, but this is positive negative, right? So that means that y is equal to both positive square root x and y is equal to negative square root x. So that means we're going to get the square root function positive this way, and then the square root function negative, which will go this way. So the square root of 1 is 1, and the negative square root of 1 is negative 1, and so on. Oh, what am I doing? Cyan. For the graph of, did it in green again? The graph of x is equal to y squared. Something like that. Okay? And now 1 over x. I'm going to do a whole different graph for this one. Ooh, why didn't that work? Okay. 1 over x. Alright. If we plug in negative x, we're not going to get the original equation. When we plug in negative y, we're not going to get the original equation. However, if we plug in negative x and negative y, we get the original equation. And that means it is symmetric about the origin. So you can flip it this way, and then you could subsequently flip it that way, and you're going to get the same exact graph. Okay? Let's try to look for intercepts. First of all, recognize that the domain cannot be 0. X cannot be 0. So you won't have a value for this function at x is equal to 0. Alright? So you'll never have a y-intercept. And you'll never really have, because x can't be 0, this whole thing can never be 0, which means you cannot set this equal to 0, which means we can't let y be 0, which means there is no x-intercept as well. So it looks something when we do points, when we do a little table, we have our input x and we have our output 1 over x. And if we put in 0, well, that's not defined. When we put in 1, we get 1 over 1, which is 1. When we put in negative 1, we get negative 1. We get 1 over negative 1, which is negative 1. When we put in 2, we get 1 half. When we get negative 2, you get negative 1 half, and so on and so forth. So you have 1 and 2, negative 1, negative 2. So 1, 1. Actually, let that be 1 half. So the increments aren't halves. So this is 1, this is 1 half. This is negative 1. Well, you get the picture. So 1, 1, and then 2, 1 half, negative 1, 1, negative 2, negative 1 half. And actually your graph is going to look something like this. It's just going to keep going on in that direction, and it's going to go on like that on the other side. And as you can see, if we flip this 180 degrees, if we flip it on its head, it's going to look exactly the same as it did before. So these are the 3 key graphs that the author of this Precalculus textbook wants you to know.